In this video, I'm going to quickly explain about potential divider circuits and their uses, which is a topic that we need to know in IB, SL, and HL physics. Alright, so first thing is you need to know that in your IB data booklet, there are different types of resistors. These are all the different kinds of resistors. In the European version of drawing resistors is just a box. Lamps act as resistors. There are variable resistors, thermistors, which vary due to temperature, light-dependent resistors, which vary due to the amount of light or intensity of light, and then heating elements, which is basically a resistor that gets hot. But all resistors get hot anyway, so it's, in short, basically a resistor that's designed for the purpose of getting hot. Alright, what is a potential divider? A potential divider circuit is simply a circuit that splits up the total voltage, or the total potential difference. So here we have a battery of 120 volts, and if you just simply put two resistors in series, that will divide up the potential difference, as we've learned already. The potential difference, if the potential difference across the first resistor is 70 volts, then the next one will be 50 volts, right? Because it should add up to the total of 120, as we've learned with the rules for voltage in with series circuits. So potential dividers, we've already been seeing this whole time, but there are different applications for why you might want to split up the potential difference in a circuit. Before we go any further, it's important to remember the answer to this question. Which resistor has the biggest potential difference when you have two resistors in series? The one with the biggest resistance or the one with the smallest resistance? The answer is that it's always the one with the biggest resistance that has the biggest potential difference drop. If the current's going to be the same through both of these, the one with the biggest resistance definitely needs the biggest potential in order to have the same current through both. Now let's go over some uses for a potential divider circuit. One of those is if one of your resistors in your potential divider circuit is that of a light-dependent resistor, you can use the resistor to help you measure the intensity of light. As the light increases, the intensity of light on the LDR, or light-dependent resistor, the resistance of the light-dependent resistor will decrease. This is because as it receives more energy, it bumps up electrons to higher energy levels, which then are more freely able to move around. So as the resistance goes down, that means that this potential difference should also decrease across it, right? So you can actually measure how intense the light is according to what the voltage is. If you somehow work out, well, with this much voltage means this much intensity, and you can know and use this device or a potential divider to measure how intense that light is. Another use of a potential divider is similarly to measure the temperature in a circuit. So instead of a light-dependent resistor, what if you have a thermistor? Same kind of thing. As the temperature increases, the resistance also decreases for similar reasons. As the temperature goes up, it raises those electrons to higher energy levels and makes them more free. So same kind of thing. As the temperature goes up, your voltage across the thermistor goes down, and the voltage over here will go up. Sometimes they make it so the electric thermometer or whatever is measuring it is based off of this voltage here. And so it knows when the voltage goes down, the temperature must have gotten hotter. And sometimes they use this resistor over here. So it's just backwards, right? Because as this voltage goes down, potential difference, that means this one has to go back up. So the total is always 120 volts. Another device you need to know about is a device called a potentiometer. Now, a potentiometer, the symbol for it is this right here in your IB data booklet. And a potentiometer actually has a third point of contact. So instead of just an in and an out, it actually has two ins, okay, and one out. So it has a third point of contact, and this third point of contact can actually slide back and forth. So in my circuit diagram here, right, you can slide it one way or you can slide it another. And the purpose of that is that you can change the path that the current will take throughout this resistor. So for example, if we followed the path that the current takes, current comes to this junction right here and then will split. Some will go up here, or sorry, some will go this way and some will go around. Okay, so the total current in green could be, I don't know, I'm making up another 10 amps, and part of the current goes this way. Let's make up a number, 3 amps. The rest of it goes this way. Let's make up the other amount would be 7 amps. Okay, but when they get to this part, halfway or whatever point it connects in the resistor, they'll combine and the rest of it will be back to 10 amps. So this means within the same resistor, it has two different levels of current. One with 3 amps, one with all 10 amps. So this one resistor can actually act like two different resistors. In fact, we often think of it as two in order to solve problems with potentiometers. So what we do is we just say, hey, look, let's take that one resistor that we used to have and let's divide it into two chunks. This current will go through this resistor, and then the total will go through that the second half of that resistor, or this part of that resistor. Now this becomes just like another potential divider. Okay, so a potentiometer acts as a potential divider, where it divides the voltage from one half of the resistor between the other half of the resistor. And what that allows you to do is it allows you to change the actual potential difference of a third element up here. Okay, so as this resistance, you can decrease it by moving the slider this way, so there's less resistance on this side because there's less of the resistor, and that means that that decreases the potential difference across this guy, and he's in parallel, so it also decreases the potential difference across him as well. Or you can slide it farther this way, and that increases the potential or the resistance on this one, decreases it on this guy, which then increases the potential difference here and across this guy. A common application for potentiometers is that of a dimmer switch. Okay, if you remember old dimmer switches, they are literally a little handle. You have a little handle or whatever that you literally slide up and down. Okay, and you slide it one way and it'll turn it off, and you slide it the other way and it turns it back on. Okay. Now what all it's doing is changing the amount of electric potential across the light bulb. So if we hook a light bulb up to over here, okay, and we can slide this back and forth, let's say we slide it all the way to the right, what would be the potential difference across this light bulb? Well, on this side of the battery is 120 volts, right, all the way everywhere over here. Okay, if it connects all the way, this connection goes all the way over here, well then it's connected to the zero side, and so the potential difference is 120 volts across this. The resistance on this side right here will be its maximum, and therefore it will be 120 volts, the maximum voltage you can get. What happens if you move your slider all the way to the left side? Okay, well in this case, you take your voltage and it's 120 here. It's also 120, it's connected right here on this side. So 120 to 120, there's no difference there. Also, there's no resistance right here because you've slid it all the way down. That means this light bulb has now been short-circuited, and there's no reason for the current to bother to travel this way when it can just go this way. So therefore, this light bulb is basically off, all because you short-circuited this light bulb. This is one of the examples of how, again, a dimmer switch works. You slide it all the way over here, it's off. You slide it all the way over here, and it's as bright as it can be because it's at its greatest potential has its greatest potential difference across the light bulb. Another example of a use for potential divider or potentiometers is that of not only just dimmer switches, but electric heaters. Okay, so an electric heater, same thing. They often have knobs, and you can get it hotter or colder by just changing the amount of voltage across a heating element. So again, they usually have something where a knob or a switch where as you turn the knob, it's just moving the contact along this potentiometer, so it's either at its maximum voltage or at its minimum voltage.